We've got a couple of comments and questions so far, and I'll parse these out to the group, and yeah, we'll get going. So I think the first one, David, you addressed it a little bit in the comments, but it looked like there was some confusion between the 82 hex and the 84 hex PSID, and I wonder if you just want to add a little bit of additional clarification or distinguishing between the two.
Well, for various reasons, ASN1 requires you to use decimals, so I just looked it up in the standard, and it's 130. But in the slides, it says 184, and those that know me know I'm totally dyslexic, so my apologies, that's a
Okay. No problem. So I just wanted to make sure we were able to clarify that to the audience. So next question, and this would just be for anyone in the group, maybe particularly though for Chuck, things you come across, and the others as well. But are there any how-to manuals for creating map files?
No, not that I've found. What I did find in MIT's, Larry Head's team created a field user's guide, and that had information about some of the items that I needed to put in the Nmap file. But again, I had to dig deep to find out what some of those values were that they'd mentioned, and that's why it was kind of difficult to find. And that's why I'm hoping that there can be a best practices manual for creating map files.
May I add to that?
Absolutely, David.
That's what the original intent of the /10 effort was to be, not so much standards, and although we've run into a host of problems, but just a practical how to do it guide. We do have a private website that's run by our company answering some of those questions, but we haven't got any mechanism of funding the effort. And one of the problems is that everybody wants to use a Google map to demonstrate. Google will let you put things up on a website, but they won't let you publish it in an SAE document. So we're struggling, but our goal remains that /10 will have recommended practices, and this online resource will remain agnostic, but be able to point to vendors and point to best practices. And I'm hopeful that a lot of those, just tell me how to do this questions, can be answered on this online site.
Okay, great. Appreciate those insights. The next question, I believe this one is geared towards Greg. Can you provide a ballpark number for RTCM implementation?
Yeah, I'm looking at that question, and I'm not sure, is that dollars?
Do you want me to take that one?
Well, I mean, a ballpark number of what? Because assuming that it's how much extra effort cost is there for RTCM? There's virtually none. There is development of software that on hardware that's already there. So if that's the question, then the answer is almost none. But I'm not sure that is what the question really is.
Well, let's focus on that, and if that didn't address it, and I'll ask the individual who typed that question to come back with some additional clarification. So.
Oh, I want to beg in a little bit more while he types. There are about 100,000 base stations in the world. There are maybe 10,000 N-trip casters. I know that because we happen to provide a free one, so we're familiar with a lot of them. This has become a commodity. It was a very expensive thing for surveyors and agriculture, but in the last 10 years, it has become a commodity. That's the future we need to prepare for here. As Mr. Larson says, it's cheap.
Okay, great. And it looks like, yes, that indeed did answer it, so appreciate the perspective from both of you. The next question, in terms of absolute accuracy requirements for maps, are there thoughts from the group on a top-level threshold?
Let's see here. This is Chuck, and we were within probably half a meter when we went out and field verified the coordinates that I had created. And for us, that was good enough for our buses. Now, is it good enough for vehicle to vehicle when you need to apply the brakes? And David, you probably have a little bit more information on this since you helped create the map standard and what you think the accuracy needs to be.
No, I get that all the time, and I haven't got a definitive answer. Sometimes the Google Map's perfect, sometimes the Google Map's not, and sometimes the Google Map changes. I live on the edge of LA in the mountainous areas, and the minute you hit the mountainous areas, we see a 30-centimeter bias. So these are really rough comments, but try to hold better than better than half a meter. Try to find some sense of absolute accuracy, because what we see is adjacent tiles, regardless of the source, are pretty coherent. But if you can just geo-rectify the whole thing, you're doing pretty good. And make sure that your resulting lanes don't have huge gaps. But I think for the accuracies that we're looking at now, before RTK becomes more prevalent, and presuming that people are using low-end L1 only U-block junk, if we can hold things well under 50 centimeters at the 30 centimeter mark, we've hit the sweet spot of accurate enough without driving up cost. I'm more concerned with cost. Map creation has to become a commodity too, not a $1,000 exercise for an engineer. Right now, I'd rather see more maps with lousier quality, but I don't have a black and white answer to that question.
Okay, any other thoughts from the group? No? Okay. So the next question, I think, Greg, this is actually directed towards you, says Gary, but with regard to the upcoming comparison between RTCM v3 and differential GPS, what ground truth would you use for comparison?
So yeah, this is a detailed question. The UC Riverside researchers are working on this, and I'm not certain what they're using for ground truth. Since they are experts in GPS, I assume they're using a hyper-accurate GPS as the ground truth, but that's mere speculation on my part. And unfortunately, I don't know. We have not received the report back from them on the results of their testing because they're not complete. So I don't know the answer to that question.
Do you want me to fill in practical advice again?
Sure, please.
Broadcasting faster than 1 hertz is a diminishing return on investment because the signal doesn't evolve that quickly. There's no real benefit between 1 hertz and 10 hertz. Less than 1 hertz, you start to notice things pretty quickly. These things are all timestamped, so that the transmission latency really doesn't affect it. People in our office are transmitting stuff from Japan to our office in LA and sending it back. No big deal. That's not the issue. Doesn't mean that half the BSMs are not getting corrections. It means that the way it works in the vehicle is the last correction is simply projected forward in a linear time sense. So it's a good question. It's just not really the root problem for using RTCM. When you've got a fix, you get 100% increase in accuracy. You hold to a couple of centimeters. That presumes that the base station is correctly located. A base station that lies moves you to whatever the base station says. Many of you have heard me say this before. The base station is God. Whatever it says goes. So it's just a question of setup more than anything else.
Okay, great. Thanks, David. Greg, I think this next question is for you as well. For the test bed in California, did you guys need some kind of black box to translate RSU inputs to the controller?
And the answer is yes. And it's complicated. For our setup, we are using a protocol called AB3418, which is not really a standard. It's something that's only available in California. The proper way to do this is the way the folks in Utah have done it. They have a black box between the roadside unit and the traffic signal controller that's based on a Linux industrial computer. And they're using NTCIP as the standard to talk to the controller. So if you're interested in how it should be done, that's the way it should be done. The way we are doing it is peculiar, and we are working as quickly as we can to replace the AB3418 with NTCIP but our signal controllers don't have software that supports NTCIP, so we're not able to do it the way that Utah's doing it and the way that it should be done. So hopefully, Hassan, that is satisfactory as an answer.
Okay, great. Thanks, Craig. So the next item, just a comment from one individual who states, last time they priced a base station, if there truly is a need, they are in the $20,000 range. Just quick, I don't know if anyone else, any of the presenters here have seen, significantly different prices, or if that kind of aligns with your own understanding as well.
Well, and let me jump in quick. As an infrastructure owner operator, we're not going to put a $20,000 piece of equipment in any of our intersections. That's why this architecture where we take advantage of free services from Ntrip servers and casters is an ideal solution. I know the auto industry, when they're testing, doesn't mind doing that, for a test setup. But if they are looking to us to put that expensive a piece of equipment in an intersection, that's not going to happen.
Hear, hear. This one base station covers, with the type of low-grade automotive junk we're talking about here, junk being a price point, not a pejorative phrase, 25 meters or 25 kilometers or so on a side. Most states have good CORS networks, continuously operating reference stations. Most of those are free. There are exceptions. The existing agricultural and survey needs that your state's already dealing with means you probably have a set of corrections. Reducing this to a translated into ASN1 and just use what you got problem. But base stations can cost anywhere from $5,000 to $50,000, depending on how many features you want.
Okay. Yeah, it sounds like there's not a pressing need for significant investment in base stations outside of what's already out there. But in the event that there is truly the need, as this individual commented, it's good to know that there's that range. So, okay. So the next question: RTCM Type 1004 broadcasts at 5 hertz, while BSM broadcasts at 10 hertz. Does that mean that half of BSMs are not getting corrections for lats and longs contained in the BSMs?
I thought I tried to answer that one before.
Yeah,
no.
I think you jumped. Yeah, David, you jumped ahead. Shanming, I hope you got the answer that you were looking for.
Oh, yep, you're right.
I think because David answered that earlier.
You did. Sorry about that. Okay, next question is, any thoughts on who is going to maintain the map data down the road via public agency or private services?
This is a really good question because with the map data, I could see, where's that data going to reside? Is it going to be in a DOT's GIS department? What about different cities when they have roads and intersections, signalized intersections? So they have their own data as well. Or can it become a commodity where you have private services going out and collecting it, and then agencies would just buy that data? And I think a lot of this comes down to how easy can map data be created for intersections? Can it be done through a company driving the intersections and collecting that information? Aerial photos, have a company doing that. So, creating the map data is a headache as well right now, but who's going to maintain that data, and where's it going to reside? That's some of the biggest issues that I see. Blaine, you might want to chime in on this because you're more in the management side of this instead of me being a technical.
Thanks, Chuck. Yeah, I think we've got to deal with the issue of how we update these going through time and keeping an eye on what changes happen in the roadway and how we monitor that, how we deal with these. That's something that we've not really given a lot of thought to since we've been so busy just building the maps to start with. We've got to figure that out.
Are there any other thoughts from the group on that question?
This is a future prediction, but I believe we become too concerned with the DSRC ASN1 representation, and I believe moving forward, something more like KML or GeoJSON will become the means by which maps are kept and maintained and exchanged with these other parties, regardless of the business model that eventually evolves for whether the state creates it or a private sector creates it, and what the quid pro quo to get your hands on it becomes.
Point. So a related question then, and I suppose depends widely on the ownership and then the method by which the map data is created. What would be a reasonable cost for maintaining map data? Thoughts from the presenters?
That depends.
What does that mean?
Yeah, reasonable cost for maintaining the data, that would, again, that comes down to how is this data being collected? How's it being, how do you maintain it? When we have an intersection that's undergone construction, who's going to go out there and get the information? So is it just through photography? Is it through an intern that you're having do it, where it can be cheap? Or do you have a contractor go out and you have a contract with them and they collect that information for you? So what's the cost per intersection? Is it $300, $400, $1,000? Until we find a better way to collect the data and automate the process of creating a map, I don't think you can get a good idea of what it's going to cost to contract that out compared to if, like someone like me who does it. But the problem that I have is, how do I know when an intersection is going under construction? I would have to coordinate with somebody in UDOT in the construction department, telling me that, hey, we've got something going on here, and we're ripping up your intersection. Because right now, I haven't done that, because the intersections I have, I already know the people I'm working with, but what about other projects in the state? And as DSRCs are deployed at intersections across the country, this, it kind of goes up exponentially in the sheer numbers, and then how do you maintain those numbers? And that's why I don't know what a correct cost would be until, if a company can come up with a quick way to do this at a reasonable price, it could solve the problem. And that's where we need to find out what the best methodology for doing this that provides the accuracy we need, because there's still a lot of handwork involved in creating attributes for lanes. It's not just dropping points down, it's knowing what the connected lanes are. So there's hands-on work. How do you automate that so you can make this so you hit a price point that suddenly is reasonable for people, meaning private companies, to do that, or even for a DOT to do that? At least that's my opinion.
I think I completely agree with that, but I'd offer another insight.
Please.
It's got to be, take a look at the current situation where people routinely retime a light. That's a fact of life, and some people have budgets for that. Whatever retiming or resyncing a map would cost has got to be a small fraction of that cost, and that sort of sets an upper bound.
That makes a lot of sense. That's helpful, David. Thanks. Okay, so a couple final questions here. Should there be a systematic assessment for reaccuracy requirements between lower signal priority versus more demanding collision avoidance applications?
So this is Blaine. Yes, I think that's appropriate, and that's why, as Greg described the position correction process, I think it's very appropriate for you to look at the application you're going to run and determine whether that correction is necessary or not. And the higher accuracy, the more demanding applications will require better data, and that would sort of push you into doing that. The same could, I don't know if this question was about maps or position correction, but the same could be said about maps. And I think David said in one of his early slides, don't build a map that contains everything. Build a map containing the things you need. And so you can base that on the particular applications you're looking to run. Now, the risk there is as automobiles start to show up with applications built onto them, and Toyota announced yesterday they're going to start doing that with DSRC, have we built maps that are adequate for those applications? And sitting here today, we don't know what those are. So the risk is you could undershoot the target, if you will, and then find ourselves a little bit short. Now, we can always go back and update the map and do those kinds of things. But as we do the analysis, I think we need to be a little forward-thinking about making sure that we're sort of ready for what might come at us.
Let me add an observation regarding this question. We were talking about RTCM corrections at an intersection, and again, DSRC has a relatively small footprint, but for collision avoidance, you're going to need that application anywhere, and it may be, and it's more likely it will be outside the range of any RTCM correction. And this is a conversation that we've had with the auto industry. Is right now we're only planning on providing that correction at intersections and maybe some limited other locations, but don't they need it everywhere? And some of the car companies say yes and some say no. So there is a need to continue exploring what the actual requirement is for GPS accuracy or positioning accuracy everywhere, not just at intersections. So that's just an observation.
So I've got another question, and this one's kind of for David. A follow-up to Blaine's comments is, if I'm driving a car in Chicago and I drive it to Los Angeles, and I'm expecting, and I have DSRC applications running, I'm expecting those DSRC applications to work from state to state. Is there a bare minimum in map data that has been, I know there's required information that's in a map message and optional components. Is the bare minimum good enough for what applications will need?
Without understanding the application, there's no way to answer that.
Yeah, and so how do you plan an intersection to put information out there if you don't know what the application is going to be? And how do we, if automakers are putting applications in their cars, how do we know that, what do we have to do to our systems to get them to work? Do they have to give us information of what's coming down the line, so we have to adjust our map data? I see this as kind of a big issue, that as a user, if I'm driving, how do I know if what I have is going to work?
It's a valid question, but I don't think I need to be the ball catcher for that one, because it's cross-cutting, and if we don't communicate with each other, we usually make mistakes. So, not to use that as a straight thing, but that's why we have standards communities that are made up of people that are roadway owner and operators and car makers and infrastructure bits and pieces providers, et cetera, et cetera. They all have a different take on it, and we try as gentlemen to come to a common agreement on what we can do today while not precluding what we hope to do tomorrow. Like I said, it's kind of a stock standards answer. Sorry.
No, that's okay. Thanks, David.
Okay, so I do see some additional questions coming in. Unfortunately, we are over time. We are at 3:32 Eastern time, so a few minutes past. But if you do have additional questions or want to follow up, you can reach out to us, and we can definitely put you in contact with today's presenters. And also, there's tons of relevant information around this accessible through the SPaT web pages on the NOCO website, as Blaine shared at the very beginning of the webinar. So with that, just a couple of quick wrap-up items. I just wanted to, again, thank you for everyone for attending today's webinar. Wanted to remind you that we have the next webinar in the SPaT series a week from today on April 24th. And that's going to focus on FHWA's map creator tool. That, there was a little bit of allusion to that earlier. Chris Stanley from Leidos, he won't be personally presenting, but he and his group at the Turner Fairbank facility through FHWA have been working very hard to develop this map creator tool, and you'll see some demo for that resource and hopefully answer some of those questions as well. I wanted to thank our panelists as well. We had some good information here today. A recorded version of this webinar along with the presentation slides will be available on our website in approximately 24 to 48 hours. And then just on behalf of the National Operations Center of Excellence and our presenters, thank you for joining and have a great rest of your day.